So now we move to the main equation, the tool that we can use for predict the motion of the particle moving in 2 dimensions. So we did learn about the kinematics equations in our 1D motion chapter, right? And all these equations can be used and explain all, like whether it's in the projectile motion or in a circular motion. We can use all these equations. It depends on the condition. But think about all of these in terms of vectors, and what you did calculate or do some calculation, whether it's in like 1 dimension along x-axis or free falling like another movement in y-axis. You separate the components and do calculation. This is not only the x in terms of the position or displacement, it can be also y in terms of direction as well. So please remind yourself about all these important of this equation. The first box is mostly related to the acceleration as a constant. But for the second box, the below one, is due to a that is no longer a constant. So now, what is happening here? You have to do some integration because it can change with the time and change with the position. We will find all these type of usage in the further investigation. So now go back to the definition of the vectors. As you know, R can represent in 2 dimensions as xi and yj, which x is the components along y-axis and y is the component along j-axis. If you like to find the velocity, you do some differentiation, right? You dip r by dt, so you got instantaneous velocities. And now this is one of the example that you can use it from the Foreman equation. But think about all these as vectors, right? As we state, like from our Foreman equation, if we look after this equation in terms of vectors, we can see it's like a combination of components of vectors, whether it's in x direction, x components, all these are x components, and all these are also y components. As you can see, the resultant vector, like a vf here, the bold one is the vector. These are all vectors, right? It's comprised of the components along the y and x. As you can see, the Vx here, Vx, the final Vx over here is the summation of the Vxi plus Axt. This is the component that you break from this one to this part and from this one to this part for your total, the final Vxf. The f is the final one. And how about in the y components? As you can see, is a sum of the y components, or what you can write down, you can represent here as all in I direction, all of these in j direction. I will write it carefully like this, and this also I and j. And when you sum it up, you got the final Vf. So you did break component to x-axis. How about the component in y-axis? Yeah, these are component in y and here y. When you sum all these up, you got the v terminal in y-axis, and sum between vy and vx, you got v final. Not only the velocities, the position vectors, it also come from like all these vector sum up together. As you can break this component to x-axis, to x-axis, to x-axis, and also to y-axis, y-axis, and y-axis. This is what you get the component in I, in J, and in J. And when you sum it up, it's your resultant vectors. Right? This is the example of the component breakdown. As you can see, you can apply the four main equations in each component. Not only the first equation and the third one, all of the equation you can use. If you have some parameter related to these equations. So let's see the problem in example 4.2. Listed about the particle that moving from the initial point at t0. This is the original. And with this particle have the initial velocities in x components only, like the Vx is equal to 20 meters per second. And also in y components, I represent u as the initial velocity in this case. So u here, in some textbook, it's write down like Vix, right? But I'm going to use like a ux as the initial one. Initial velocity in x components. And how about in y component? You got uy equal to minus 15 meters per second. If you write down as a vector, this one along y-axis, this one along j-axis. If you got a unit vector as I here, and upward as a plus j, so downward is the minus j. The particle move in xy plane, so we focus only in this plane. So you have only acceleration along x-axis, right? Not only is moving with this u, it also have ax as well. Yes, 4 meters per second square. But in y direction is 0, so you don't have any acceleration along this part. So you can see this moving look like a projectile, but not due to the acceleration from the y-axis, but from the x-axis. The question is to determine the components of velocity vector. So they would like you to determine the Vt. What about this? Right, at any time point. So this is supposed to comprise of the components Vxt in I direction plus Vyt in j direction. This is their total velocity at any time point. Right. It's comprised of the Vx, which is x components, and Vy is y components of the velocities. So how to determine it? As you can see, in y direction is simple because it's moving with constant velocity. So you got Vy component first. So your Vy component at any time point gonna be constant. It's gonna be equal to Uy. So your Vyt is minus 15 meters per second. As the vector, your Vy is minus 15 j unit as meter per second. And this is how you get the information of the velocities. How about the Vx t? You have seen the Vx got some influence of acceleration, so it's not gonna be constant all the time. So Vx supposed to have some relation with the acceleration, right? Think about a four main kinetics equation. kinematics equation. Right, you got the first one is v equal to v0 plus at. The second one, the displacement s equal to v plus v0 over 2 multiplied by t. And the third one is s equal to v0t plus 1 over 2 at square. And the fourth one is v square equal to, equal to, I will write on above part because it's about at the bottom of this PowerPoint bit, and it can be getting worse if I'm touching all these panel. V square equal to u square plus u, which is like v0 in this case, to as. Right, you can use this whether it's in x components or in y components. This is your kinematics equation here, 4 main kinematics equation. As I note down here, I'll box it up. Note this. So if you got some relation of v and you would like to have some v with the time, so you have some a with the function relate to a and also relate to time as well, right? So what it can be, so I will pick the first equation. So you're gonna get the v, I will pick up and write that here. You will get v equal to v0 plus at for this relation. Since it happened only at x component, so I will write down as vx equal to ux plus ax t. Time like universal, but we look after only in x component. Since y component we already look after it, right? We finish on y component to get this already. Now we would like to finish the x component, so you sub the vx in. If you like to find the vx at any time point, it's come from ux, like initial velocities. What is the initial velocity? Here it has the initial velocity as 20. So you got 20 meter per second plus acceleration 4 with the time. So this is your vxt. If you write it as a vector, you know it's in the I-axis, which is I component as the x-axis. So now you got y component showing here. This is your y component. This is your y component. I will rewrite it, sorry. Y component here, and this is your x component. So now you can sum it up. So your final Vt, this is the total velocity at any time point as the Vx. So you got 4t plus 20 in I direction, and plus the Vy, which is minus 15. So I'll write it as minus 15 J. The unit is meter per second. So here you can use all these useful information to explain the motion in 2 dimensions, which is in I and J unit vector direction. So to calculate for B, now we would like to define the velocity, which is vector, and the speed, which is a scalar, of this particle that moving at the time point t equal to 5 seconds. From the previous results, we got Vx, Vy, and the V total already, right? Which is your V total, the net velocities is 4t plus 20 in I direction and minus 15, right, in J direction, unit in meter per second. If you would like to determine the velocity at this time point, you can sub t equal to 5 in, so that you got 4 multiplied by 5 plus 20 I and minus 15j meter per sec. So this is 40I minus 15j. This is your V at t equal to 5 seconds. So how about the speed? This is your velocity. So for finding the speed is the magnitude of the velocity. You can find the speed from two definitions, right? This is asking you to find the speed at this time point. So this should be the magnitude of your v t equal to 5 seconds. But you already know, like, if you would like to find the speed, if you know the total distance and you divide by the time, that the definition of the speed as well, right? But in this case, we're gonna find the speed from this definition. So to find the speed, if you would like to find the magnitude of Vt equal to 5 seconds, is the square up of these components and sum it up under the square root. So you got 40 square plus minus 15 square, right? And no, it should be outside, and then square root them. So finally, you get the magnitude of the speed of this v at t equal to 5 seconds equal to 43 approximately. So it's not 42, sorry, 43 meter per second. Don't forget you need about this as well. This is also meter per second as well. So this is your speed. Next, in order to determine the position, xy position of this particle at any time point, so how can you define it? As you get a relation of r, t, right? This is the combination of rx in I direction plus ry in j direction. And since you already know that the Vt is the Vx I plus Vyj, which is equal to the previous one, the 4t plus 20 I minus 15j. This is meter per second, this is meter in unit. So we already know this. If we would like to find r, how can we derive it? Yeah, you can use the relation of instantaneous velocities. The definition of instantaneous velocity or Vt is come from, you got the dr by dt that equal to v. And from this case, you can do some integration dr and v dt like this. as you already know, you can set the limit, right, from R0 to R, and from T.0 to T, which is your V is your instantaneous velocity. So you can sub that instantaneous velocity in, as you got 4t plus 20 I and minus 15 j dt. So these gonna integrate the whole Vt over here. What you get from this part, I will write down further here. So you do integration of this term, you get r with limit r0 to r equal to this integration 4t squared, and you have to divide by the factor of this integration, and don't forget to put the limit from 0 to t, and plus 20t from 0 to t, and this in I component. You can do it separately, or you can work inside the vector. It depends on your how to say, your caliber or your experience of solving this problem. In this case, I will show you how to do it as quick as possible, but you can do different from what I'm teaching you. It depends on your choice. But from this, now we have to integrate the other term as well. So you got the minus 15, and you integrate by dt, you got t out of it, and put the limit from 0 to t, and these are in j direction. After you do this integration, I will write this. It looks like you're going from right to left, and left, go back to the right again. So now you got these as r minus r zeros, which is start from the origins. Here you can see the origin is represent that you have r0 equal to zeros, which is in I plus j meter. So the origin is represent xy coordination as 0, zeros. Right, this is at origin. So that means your r0 is equal to zeros. This is equal to this substitution in, so you got 2t squared plus 20 in I direction, and minus 15t in j direction. So your final result is rt at any time point, because you integrate with the limit of any time point. So now you got the final result as 2t squared plus 20. Don't forget that you have t over here. Yeah, be careful about this as well, because when you have these kind of line, you can mix up easily. T I minus 15t j in meter unit. This is what this problem asking you to find out. If you already know the condition of the initial velocity, and you know as some components can have the acceleration, especially it's not only in only x or only y, it can be both of direction that have the acceleration. So make sure you understand this part and can solve to the final equation as finding this RT.